In this session, we study the second case of tachometry, and that is line of sight is inclined and the staff is vertical. From this statement, we can draw a first figure. At this point, instrument is placed. That is tachometer. Tachometer, and here we place a staff. As we know, the staff having alternate color band, and list count of the staff, that is 5 mm. Then, in our statement state that the line of sight is inclined and staff end is vertical. Means here the staff we place and it is vertical. Then line of sight is inclined means the direction in which we see the or bisect the object, it is inclined. This is our top hair reading, axial hair reading, and bottom hair reading. From this, we take a distance and difference between bottom and top axial hair reading is known as staff interface and denoted by S. Okay. The horizontal distance between the instrumentation and the staff is known as horizontal distance and it is denoted by capital X. Then the point at which we place the instrument is denoted as P, station P, and where we place the staff, it is denoted as A. From this, we have to calculate the horizontal distance. From this, we have to calculate the horizontal distance and the vertical distance. Means from this here, from ground level to axial hair reading, this distance is known as the vertical distance and denoted by V. Here we show this distance, vertical distance and horizontal distance. The distance between instrumentation and the staff, it is known as the horizontal distance and denoted by capital X. And the distance between ground line and the central hair reading is known as the vertical distance and denoted by the capital V. And in this case, we have to calculate the horizontal distance and the vertical distance. Firstly, we find out the horizontal distance, that is horizontal distance. Horizontal distance. What is the formula of horizontal distance? In the first case, that is line of sight is horizontal and the staff end is vertical. That is, horizontal distance is denoted by X and it is calculated from formula L cos theta. Then what is the formula for the first condition of tachometry? That is F upon I into cos square theta plus in bracket F plus T into cos theta. From this formula, we calculate the horizontal distance. When the line of sight is inclined and staff is vertical, then we use the formula for finding the horizontal distance is F upon I cos square theta plus F plus C cos theta. in this condition, what is meant by theta and how we calculate the theta? It is the inclined angle. It is the inclined angle between the axis of instrument and the central here reading. Theta is the angle between axis of instrument and the central here reading. From this we calculate the theta and put in this formula. After calculating the horizontal distance, now we calculate the vertical distance, that is capital V. Vertical distance, capital V is equal to N sin theta, and we can calculate by using the formula F upon I into S here, F upon I into S into sin theta, sin 2 theta divided by 2 plus F plus 3 sin theta plus F plus 3 sin theta. By using this formula, we calculate the vertical distance. Now we solve the numerical on the second case, that is the line of sight is inclined and the staff hand is vertical. Now we start the first numerical. The question given is, that is determine the between instrument station A and staff station B by using following details. Now we see what details are given in the numerical. First, the vertical angle, that is the vertical angle is given, and the vertical angle given is plus 5 degree 40 minutes. After that, the staff reading is also given. It is staff reading, and the given staff reading is 1.255. Then second staff reading, that is axial here reading, is 1.860, and the bottom here reading is given 2.465. After that, value of multiplying constant and additive constant is given, and the given value for multiplying constant is 100, and for additive constant it is 0.3. Then last given data is RL of instrument axis is given, and it is 400 calculate the area of B. From this given question, we have to first draw a figure. Now, in this numerical, firstly, the vertical angle is given, means theta is given, a staff reading, that is top here reading, axial here reading, and bottom here reading is given. Then multiplying constant, that is f upon I. The value is given 100, and additive constant, that is f plus e. The given value is 0.3. Then RL of your student axis is also given, and this is the 400. Now we have to calculate the horizontal, vertical distance, and the RL of B. The RL of B means at B point we place this staff, so we have to calculate the RL of the staff. Firstly, we draw a figure from the given data. Here we place the instrument as given. The instrument placed at the point A, so we note at A, and the staff and at station point B, we provide a station B. Then after that, here readings is given. That is the top here reading is 1.255. Then axial here reading is 1.860, and bottom here reading is given, that is 2.465. Then after the theta is given, means theta means what? When the earth shakes, when the ground. And here reading, that is theta given is 5 degrees 14 minutes. Instrumentation and the staff station are denoted by X. Now we have to calculate the vertical distance, means distance between the ground level and the axial reading, and denoted by the capital D. Firstly, we calculate the horizontal distance and vertical distance by using the formula. First, we calculate the horizontal distance. That is horizontal distance. That is capital X is equal to F upon I into S into cos square theta plus F plus C into cos theta. Now we put all the values, that is F upon I. The value of the multiplying constant is given, and the value is 100. That is 100 into S. The staff intercept. How to calculate the staff intercept? That is S is equal to bottom here reading, and the given bottom here reading is 2.465 minus top here reading, that is 1.255. Then calculate how much it comes. That is 1.210 staff intercepting. Then value of S is 1.210. Then cos square, and theta is 5 degrees 40 minutes plus calculate the value, calculate the answer. The answer is 120.12 meter. That means the horizontal distance between the instrument and staff is 120.12 meter. Now we calculate the vertical distance. Second one, that is vertical distance. That is capital B is equal to F upon I into S into sine 2 theta divided by 2 plus F plus C into cos theta. Sorry, sine theta into sine theta. Now F upon I, the value is 100. Then staff intercept we already calculated, that is 1.210. Then sine 2 into theta is 5 degree, 40 minutes divided by 2 plus F plus C, that is 0.3 into sine 5 degree and 40 minutes. Then calculate the answer. That is vertical distance, and the vertical distance is 11.92 meter. The vertical distance, which means the distance between the ground level and the axial gravity, is 11.92 meter. After calculating the horizontal distance and the vertical distance, now we have to calculate the RL of B, means the reduced level of the staff station. Now we calculate the reduced level of the staff station. Now we have to calculate the RL of B, that is RL of B, and at point B we place a staff. Then by using, that is RL of instrumentation, the RL of instrumentation value is given plus V for what? Vertical distance, that is distance between the ground level and the axial gravity. We calculated already and it comes out 11.92 minus H. H means what? Horizontal distance. This also be calculated. The RL of instrumentation is given in the numerical and the given value is 400. That is 400. Then V for vertical distance we calculated is second step, and the answer for the vertical distance is 11.92. And after minus H for horizontal distance, and we also calculate the horizontal distance, and it comes out 120.12. 120.12. Now calculate the RL of station B. That is 400 plus 11.92 minus 120.12. The answer comes 410.06 meter. That means RL of this staff is 410.06. In this way, you have to calculate the horizontal distance, vertical distance, and RL of the instrumentation. In case of when the staff held is vertical and the line of sight is inclined.